Okay, so let's start with IP virtual router command, right? So basically, if you guys remember, we have two different types of right commands we use. One is IP virtual router command, which also we also called as VAR, right? And another is IP address virtual, which also we will discuss. Okay. And the basic difference we discuss is IP virtual router command. We will have physical IP address, right? We will have physical IP address of same subnet and virtual IP address. So if you have two VTAP pairs, MLAC pairs, you will have different physical IP addresses, right? Between on this VTAP, individual VTAP. However, virtual IP will be common. And this IP, virtual IP, or we can say it as a VIP or gateway, right? Which will be common for all the other VTAPs, right? So if you have, let's say 50 VTAP pairs, everywhere your virtual IP for this VLAN SVI10 will be same, right? But physical IP address will differ on each of the device. So here it will be 4, 5, MLAC pair, right? 6, 7. So this is the physical IP. And we will also have virtual MAC associated with this, which also will be common across all the VTAPs, right? So is it clear? Any question on this? Okay. So now moving to next is what if we want to send out app, basically what is the format of app request and reply, right? So app request and GARP or ARP reply, right? So let's check that out. So first, okay, so first app request, right? From switch to host. So let's say this switch wants to understand the ARP or MAC address of this particular host. It has to send out ARP request, right? And what should be the format? What format it should use? So as we can see here, Ethernet source MAC is physical MAC, right? Switch 1 MAC, physical MAC. Sender hardware address is also physical, right? And sender IP address is physical IP of the interface, VLAN, that SVI, right? So we have two IP addresses, right? On previous slide, two IP addresses, right? This is physical. Okay, this is physical and this is virtual. So when it has to switch, has to send out app request, it will use physical IP address and physical MAC. Okay. So let me. Okay, yeah, this one. So let's go to our topology and we'll discuss that, right? So that it's easy to understand. So this is our topology we have been using, right? So this is host 1, H1, IP address is 100.1.1/24 and gateway is 100.1.1.10, right? And this is two MLAC pair, VTAP1, we can say, right? 111 is the VTAP IP address, loopback IP address, and 555 is the virtual VTAP IP across all. Okay. And this is the configuration. So we have interface VLAN 100. Physical IP address is 100.111 for this VTAP, 100.112 for this VTAP, and then 100.113.114, right? Virtual address, which is the gateway for this SVI, is 1.10, which is same across all the VTAPs. Okay. Similarly, VLAN 200, we have this is physical IP address, and this is virtual IP address, right? And then do you have another routing VTAP and bridging VTAP? Okay. Any question on this topology? So we are using VARP, right? Between these two. Is it clear? Topology is clear. One bridging VTAP, one route, this routing VTAP, and this is routing VTAP with two MLAC pairs. Okay. And this is host 2, which is SVI, different SVI, right? 200, and host 3 also different SVI 200. Okay.
Okay.
Okay. Now let's discuss, right? Let's say we want to ping from H1, H3 to H1, right? what will happen? So H3 will send out packet to the gateway, right? App requests to know the virtual MAC of the gateway IP address, right? And let's say this is, we'll come back here that when it has to reply back. But first we want to concentrate on the other part. So right now, let's say this is replying back, okay? And app result, it sends out ICMP packet. So it sends out ICMP packet to the gateway. It received the ICMP packet in VLAN 200, right? It will check the destination IP. What is the destination IP? 100.1.1.1, right? 100.1.1.1, it will route from VLAN 200 to VLAN 100, SVI 2 to SVI 100. And then it has to send packet to 100.1.1.1, for which it has to know the MAC address, which is H1, right? It has to know the, so it will send out ARP request, right? So this guy has to send out ARP request for the MAC address of the host one. If this packet, ICMP packet lands on this VTAP, then it DO 450, then it will send out ARP request. If this packet lands on through ICMP, right, spine, ECMP, it might land here, then this guy will send the ARP request, right? Is it clear? Any questions so far?
No, Vishal.
Okay, so basically H3 is sending ICMP packet for this host, right? It routes from VLAN 200 to 100, and then now it has to resolve the ARP for the IP address, right? It is sending ARP request, right? Now we already discussed the format of ARP request, right? What is the format of ARP request? This one, right? First is Ethernet ARP sender MAC is switch MAC, and sender IP is interface IP, right? And obviously sender MAC is switch MAC, to Ethernet MAC also will be switch MAC, physical. Switch means physical, right? All this is physical. If you see, notice everything is physical, right? There is no virtual. So this is the ARP request VTAP1 is sending, okay? So this ARP request VTAP1 is sending, or whatever, either of this. So what it will send? So source MAC is B, physical MAC, right? It will use physical MAC, right? Destination MAC, obviously, this is ARP. Yellow is ARP request. So destination MAC is 00. It wants to know what is the MAC address of target IP address 100.1.1.1. And what is the sender IP it is using? It has physical. Two IP addresses, right? One physical and another virtual. Which one it is using? Physical, right? Why it is using physical? Because the MAC, source MAC is also physical. So if you use one physical, everything should be physical, right? That is the rule we will discuss. But as of now, you can just remember, if one thing is physical, everything should be physical as of in this, okay? So you have physical MAC, and we will also discuss why physical, why can't we use virtual MAC, right? To send out ARP requests. So now physical MAC, physical sender IP, right? And this is Ethernet header, where again source MAC will be B, physical MAC, and then FFF. Is it clear? Any question on this?
It's clear.
Perfect. So now this H1 will reply back, right? H1 has to reply back to this ARP request, right? So let's send out reply, right? So what will be the destination MAC of reply? B, right? B. Source will be destination, and source MAC is H1, right? Again, here it's a B, source MAC is H1, source IP is sender IP is 1, and target is 2. Clear? So this is our reply now. Host is sending. Now, because this is port channel, right? It's possible it might send ARP reply out from here or from here. Let's say it is sending out from here, right? What this VTAP will do when it receives this ARP reply?
Forward over the P-link to the switch B.
Right, yes. So basically it will first check the switch destination MAC, right? It's not own MAC. It's not its own MAC, right? So basically it will understand I have to forward this packet, right? It will also, and it will check the destination MAC B. If it has already learned through peer, then it will directly forward it to the peer. If it is not learned, then it will flood the traffic, right? So basically this app reply will end up here on this VTab, who has initiated app request, right? It has initiated app request, it got the reply. So it will update its table that, hey, to reach 100.1.1.1, the MAC is H1. And similarly, when this guy also receives the app reply, right? It also has SVI configured. So it will also update its own app table that, hey, if you want to reach to this IP, right? 100.1.1.1, this is the MAC, right? So basically, our purpose is solved that this guy who wants to learn the ARP, it will finally learn the ARP, right? Get the ARP. Is it clear? Any question?
Oh, it's clear.
Okay. Now the point is we discussed that, hey, it will send out, this ARP request. Let me change this to ARP request again, right? Back to. Okay. So now we discussed that, this app request will be physical, right? Physical MAC. Why? What if we use virtual MAC? Can anyone tell me what can be the problem? Or is there any problem?
I guess if it hashes to the wrong switch that didn't ask for the ARP, it'll consume it, and the switch that asks for the ARP will never get the ARP reply.
Yes. So yeah, so basically let's discuss. So this source MAC or sender MAC is VM, virtual now, right? So because this is virtual, we have to, this also sender IP also we have to make it virtual, right? As per rule, if it is physical, virtual, everything virtual. So here also we have to change it to 10, right? Correct. Now this app request received here, correct? This app request received here sent by this VTab. Now, as you know, you mentioned, this reply might go to this side, right? Now this app reply comes here, and if we reverse this, this will be destination MAC, right? And this will be destination target IP. So basically it checks the destination MAC, which is virtual MAC, which is present here as well. Here also we have virtual MAC configured, right? So what will happen? It will consume this packet. Obviously it will update the app of its own, right? But what about the VTab who has sent out app request originally? It will never get that app reply back, right? And basically whatever traffic coming here, ICMP, that will get dropped here, right? Because this guy will never resolve the app, right? So as Kamil rightly said, that's the reason, we need to have, or we are using physical MAC, not the virtual MAC, right? And because we are using physical MAC here also, it will be physical IP address. Is it clear? Any question? If it's not clear, we can discuss again. Anyone? Any question?
No, Vishal, I'm good.
Okay. Okay. So basically, we understood about this part, right? ARP request. Now let's discuss GARP or ARP reply, right? So again, H3 wants to communicate to H1, right? H3 sends out ARP request for the gateway, correct? Request for the gateway. Now this guy has to reply back, right? What it has to reply back? ARP, that, hey, to read the gateway IP address, right? This IP address gateway, which MAC it has to associated with this ARP reply? It should be physical MAC or virtual MAC?
Virtual.
Why?
because it's a virtual IP.
Yes. So yeah. So first thing is, yeah, the request is for virtual IP, right? It will always ask because you will configure gateway as virtual, right? This 200. Sorry, this 200. My bad. Right. So you will first request came is for virtual, right? So you have to give basically reply back with virtual MAC. But let's say we reply back with physical, then what problem can happen? Let's say instead of virtual MAC, we reply back with A. What can happen? Here your ARP is learned for 1.10 with A, right? Now sometimes some other device responds back with physical, it will again flap to C, right? Or B, correct? So basically your MAC will continue fail. Another is if your gateway is resolved with physical MAC A and this device goes down, it's a black hole, right? This is again, we come back to the idea of virtual IP, right? Or active scenario or VARP, right? That's why we always want that virtual IP should be and virtual MAC, right? That's the reason that, when this guy receives the app request, app reply should be with virtual MAC, right? One is reason is it has requested for virtual IP, right? MAC. And again, if we use physical, there will be problem, right? So this is our reply packet, app reply packet, right? So what is the sender IP? So this is app reply. So sender IP will be 1.10 virtual IP, right? Target IP is 200.112. So where is that? Okay, I think yeah, here it should be okay, 1 minute. Target IP is yeah, 2. Sorry.
Yeah. It's 3.
2. Okay. Sender MAC is virtual MAC. We will reply back with virtual MAC, right? Destination MAC is H3 who has initiated ARP request, right? So this is our ARP packet, ARP header. Top of it, we will add Ethernet header where again destination MAC is H3 who initiated ARP request. Source MAC is VM, virtual MAC. We are sending ARP reply through VM, virtual MAC, right? Now, on top of this, we will add a VXLAN header, right? Where we have source IP, outer source IP, and outer destination IP, correct? What should be the outer source IP? We have two IP address, right? Loopback 1.1.1.1 and another virtual VTAP IP 5.5.5.5. What should be the reply? With which IP address? Source IP.
Virtual.
Virtual. Why? What if we send it out with 111?
Again, it will the same problem. VTAP will flap. VTAP
yes, VTAP virtual MAC will flap between 111 and let's say 222 also replied back then in between 222, right? Agree? So that's the reason again, same, that rule comes into place. If you have virtual, everything virtual, the outer IP address also should be virtual. So basically it's thumb of rule. If MAC is virtual, everything is virtual, even outer IP address. If MAC is physical, everything is physical, even outer IP address. Okay. So this is the rule of thumb to avoid all these issues, what we have already discussed, some of them, right? So yeah, so basically we have, and outer destination IP is 3333 because we know to read this at 3, we have updated our MAC table that it is behind 333. So we'll directly send this app reply packet, which we received here, to this VTAP and then it will receive here. Okay. So that's why this is the ARP reply packet where we have sender as virtual, and because this is virtual and sender IP is virtual because request also came with virtual IP, our outer IP address is also virtual VTAP IP. Similarly for GAP, gracious ARP. So with warp configuration, this configuration, this device is continuously keep on sending gracious ARP, right? So everyone will send, keep on sending gracious ARP for its own IP address, gateway IP address for all the SVMs. So for GARP also, your packet format is same. Any question? If any of you are not clear with this too. Definitely it's difficult to even sometimes I also have to recollect or remember, remind. I mean, it's not top of my head many times. So don't feel that maybe you might not be able to remember this. But once you look at it, maybe it might gradually, you might understand that, hey, why virtual, right? Or why physical?
Yeah.
Okay. Any question? Okay, so this is the rule what we already discussed, right? What is that? If Ethernet source MAC of original frame is physical, right, which is here, Ethernet source MAC is physical, right? Physical. Outer source IP will be primary IP address. In this case, it's not there, but we'll discuss that. And if your Ethernet interface is virtual, this physical MAC is source MAC is virtual, your outer IP also will be VTAP IP, virtual VTAP IP. So if this is physical, this will be physical. If this is virtual, this will be virtual. Okay. So now the point is when this will be physical, right? When in which traffic this will be physical MAC. So that is data traffic. Okay, so let's change this to ICMP traffic. Okay, so what we are going to do is H1 is sending packet to H3. Okay, so H1 was send packet to the gateway, it resolves the ARP, everything is done, it sends ICMP packet to the gateway, right? Now what you have to do, you have to encapsulate the packet, because to read the H3. So basically it will route the packet from VLAN 100 to 200, right? Destination is 200, source is 100 VLAN, so it will route the packet. It will send out ARP request for H3 gateway, H3 IP address. It resolves that. He knows that it is H3 MAC, right? So basically H3 MAC. Now it has to send out ICMP packet, right? So let's send out ICMP packet, send ICMP. So we need source IP and destination IP, right? This is all. So source IP is 10, gateway 200.1.1.10, 200.1.1.10. Target IP is 2, 200.1.1.2, right? Source MAC. What should be the source MAC? It should be virtual. Okay, sorry. So source sender IP also will be. Okay, so we have now here two things, right? What should be sender IP and what should be source MAC? ICMP packet, data traffic.
The physical IP and MAC.
Okay, yeah, let's put that, right? So what is the physical IP? 1, right? 1. 201, right? Physical IP. If IP is physical, what should be the MAC? A, right? Now this is physical. This is physical. What should be the outer source IP?
That was the VTAP 111. Yeah.
111, right? So now let's understand, right? So we decided to keep it physical, right? Now let's see whether this is working or not. So
Vishal, in this
yeah.
source IP should be 100.1.1.1, right? It's coming from H1.
Oh yeah, yeah. Yeah, that's right. Let's change that, right? Perfect. So this is 100. Yes, it's ICMP, right? So 100.1.1.1. Yes, this is 100.1.1.1. And otherwise, okay. So now we are left with what should be the source MAC, A or VM, right? Virtual MAC. And based on that, this also will change. So as of now, let's take it as a physical, right? We send out ARP request, right? ARP request is sent here, correct? sorry, ICMP packet is forwarded here to this guy. This guy will reply back. It will reply back with which MAC? Destination MAC A. So even though it lands here, this guy knows, hey, A is here, and this basically your ICMP ping is successful from this VTAP, right? Make sense? What about if you have used VM, virtual MAC here for data traffic?
Hello.
Yeah.
Sorry, Vishal, your voice was cutting out.
Is it fine? My voice is fine?
Yeah. Now
Okay.
it's.
Yeah, I think I see a couple of drops.
Yeah.
Okay, so as we discussed, right, we decided to use physical MAC, right, for ICMP data traffic. For data traffic, we are using physical MAC. What if we have used virtual MAC? Obviously, this would have changed to 555, correct? But when your reply comes back, it goes to virtual MAC, which is everywhere. It might land here, and then your ping will not be successful, right?
Yeah.
Correct. So if you have ping from here, basically, obviously, if you have ping from here, which we have done, then it will be there. It will come out. Basically, it will route from 200 to 100 and then send it to this guy. But obviously, it will not be base path. Okay. So that's why for data traffic, we will have physical MAC, and that's why we will have physical VTAP IP. Okay. So that's the whole idea about what should be the physical IP, when we should have physical MAC, and when we should have virtual MAC. And if we have physical MAC, VTAP IP will be physical VTAP IP, virtual MAC, outer VTAP IP will be virtual VTAP IP. Okay. Any question? And last, yeah.
If you go back to the diagram where you're sending the ICMP traffic.
Yeah.
So you know how the request makes it to H3 from H1? The return traffic coming from H3 going back to VTAP1, you said it could land on, for example, switch B, and then it goes over the peeling to switch A. So it can still land on switch B, and then switch B will I guess it's doing routing, right?
Yeah. So basically, yeah. So basically, it will land it here, right? So okay. So let's understand that this has to send out packet, right? H3 has to send out ICMP reply packet, right? What it will do is it will send out to the gateway, correct?
Yep.
So yeah, so it send out to the gateway now through spine. My bad. I think I missed this point when we discussed before this for reply especially. So when H3 reply back, right, it will reply back to the gateway, right? VM MAC, virtual MAC, right? Because gateway is associated with virtual MAC. So destination MAC is virtual MAC and gateway is 200.1.1.10. When it comes to spine will check that 200.1.1.10, which is the gateway, it can send packet to any of these VTAPs, right? Because it's ECMP. So it might send this packet to here or here. When it receives here, it will check that IP address is gateway IP address is my, right? The MAC, destination MAC is virtual MAC, it's my MAC. So it will route the packet to 200 to 100 and then forward the traffic to H1.
Okay, yep.
Okay.
But I guess like what my question was is, you know how in the top left in the packet you have source IP is 111, right? As the VTAP.
Oh, yes.
So if you have the return packet, which will be destination IP is 111, so the VTAP will be switch A and switch B as the destination. So either one can receive that packet and then process it and then route it out to H1, right? Doesn't need to go over the peeling.
No. So okay, I got your point. So your point is this packet comes here, right? And sender IP, outer IP is 111, but it is decapsulated here, right?
Mhm.
So basically what we are making sure is if you want to go to a MAC, right? It's behind VTEP 1.1.1.1, right?
Yep. Yep. Ah, I see.
We'll
Okay.
update.
I understand why it needs to go with the peeling. Yeah. Yeah. No worries. Yep.
Yes,
I got it. I got it.
you got it, right? So basically we will update this. But when it comes to the ICMP reply, it's a new game, right?
Mm-hmm.
What it does, H3 will send out to the gateway and virtual MAC. So it sends out to the gateway, right? It comes here encapsulated. Now virtual MAC, it knows that, for virtual MAC, it is 5555 outer IP, correct? So it
Okay.
will send packet destination IP as 5555 here, right?
Mm-hmm.
And 555 is everywhere. So it might land to any of this. And once they decapsulate the outer target IP, destination IP is this guy. So, and it will resolve the MAC here and it will send it here this way.
Okay. Okay. Yeah. Yeah. Makes sense. It's not optimal path, but it'll still work. Yeah.
Yes, yes. Yeah, so I think I missed when H3 we discussed H3. I basically took directly target IP, but it should be encapsulated via virtual VTEP IP, right?
Yeah. No worries. Yeah. I understand.
Yeah.
Yeah. Thanks. Thanks.
Okay. So any question on this? Okay. So now next come is IP address virtual, right? Now, what is the advantage of this compared to the previous one?
Subnets are saved.
Yeah. Yes. Yes. So if you see here, you know, yes. So we are saving the IP address, right, of total host, because now we don't have physical IP. We don't have physical IP, right? We have only virtual IPs and virtual MAC, obviously. Only gateway IP, VIP. That's it, right? Now let's discuss this, right? With same our topology, right? This is our topology, correct? Let's say, H3 wants to communicate to H1, it will send out ARP request, it will get the reply back, and then it sends the ICMP packet data. Packet came here in VLAN 200, right? Gateway. It comes to the gateway. We change 200, VLAN 100, because destination IP is this guy, 111. And now we have to, this switch has to send out ARP request for this guy, right? It has to send out ARP request for this guy, H1. Okay. Can you tell me ARP request, what will be the IP address? Let's start with sender IP address. What will be the sender IP address?
100.1.1.
100.1.1.1. 1 is this guy.
Yeah, H1. Okay.
No, we are sending ARP request from
Okay.
VTEP to host.
Okay. From
So basically you got the ICMP packet here, right? And now you have to send it to H1.
100.1.1.10.
10,
That's
right?
Yeah.
So we have only this. Do we have a possibility of physical IP address here? We have not configured, right? Sorry, we don't have physical IP. See, if you compare with VARP, previous one, we used to send physical IP address as a sender IP, right? When we are sending ARP request. So if you remember this, we are sending physical IP address, interface IP, not gateway IP, VIP in ARP request in VARP. But here, because we don't have that, right? We have not even configured. So how can we use this IP, physical IP? So that's why what we are going to do is we are sending out ARP request with this IP. What is that? Virtual IP. Oh, not this one. This, right? Virtual IP address 10. Is it clear?
Yep.
Mhm.
So now this is what will be the sender MAC.
The VMAC that we configure.
VMAC, right? Why? Because now this is virtual IP, right?
Mhm.
Virtual IP. Now this is virtual, so your MAC is also virtual, right? And this is ARP, and your send Ethernet also will be virtual, right? So in case of IP address virtual, you will have everything virtual, right? Virtual IP address, because you don't have physical IP on that SVI. And because you have used virtual IP address, you have to use virtual MAC, and also Ethernet header is also virtual MAC, everything virtual. Is it clear?
Mhm.
Yeah.
Right? So basically, when you send out app request here, you have virtual, right? Now what? H1 will reply back, right? What happens? What can happen?
It could be hash to VTEP switch IP.
Yes. So it might come here, right? And what will be the app reply? App reply VM. This is H1
One
VM H1
H1
1 and 10,
10.
right? It comes here. What will happen? It checks the destination MAC, virtual MAC. It is there here. It's there, right?
Will consume the
Yeah.
packet.
And so yeah, so basically it will consume this. So what is the problem again here? Who initiated ARP? This guy, right?
Me.
B. And reply is consumed here. This guy has the updated its ARP, right?
Mhm.
So the problem is what we discussed with VARP also, that if you use virtual MAC, right, packet might get consumed here, and this guy will not receive the reply. So what should be the solution? So solution in this ARP request, because here we don't have any other way, right? We don't have physical IP interface SVI, and because we don't have physical IP, we have to use virtual IP, right? This I changed this ARP request. Because we don't have physical IP, we have to use virtual IP and then virtual MAC, and packet might get consumed here. So the solution for this is, in MLEC pair, we do ARP sync. So what does that mean? If any of this receives the ARP reply from the host, it will sync with the other VTEP pair, so that this also will learn the ARP request, update the ARP request with H1 is associated with 1.1. Okay. So basically with this IP address virtual, we do within MLEC pair ARP sync because of this problem. And that is called ARP sync feature. Okay. So if you receive the packet and any ARP reply from host on any of the VTEP, it will sync with the MLEC peer, and both will have updated ARP. Is it clear? Any question?
This is only in the case of IP address virtual, right?
Yes, this is only in the case of IP address virtual, because if you remember for VARP, anyway, this guy will receive the ARP reply, right? Because
Yeah.
the MAC is physical MAC, right?
Mm.
So we don't need this with VARP, but here we need this. Okay, make sense?
Yeah.
Now, one more point here is who takes care of this ARP sync, right? We have different agents, right? MLEG agent, STP agent. So who will take care of this added functionality to sync the ARP? So that takes care by VXLAN agent, right? Some agent has to take care of this, right? So who takes care of this? VXLAN agent. What does that mean? You should use IP address virtual only in case of VXLAN. Okay. If you might have seen that many customers don't use VXLAN, they just use MLAG, right? And VARP or VARP, active, right? In that case, you should not use IP address virtual because AppSync will not work because you are not running VXLAN. Unless you have configured interface VXLAN 1, right? This AppSync will be activated. Otherwise, it will not be. So basically, the point is with only MLAG without VXLAN, right? You should never use IP address virtual for active. You should use VARP. Clear?
Yes. Yep.
Okay. And that is mentioned here. So it's not that you have to remember. It is mentioned. Yes. Do not use IP address virtual, right?
Yeah.
Okay. So yeah, any question on AppSync feature? Okay. And again, so we discuss here. We discuss here about APP request, right? When this guy has to send out APP request to the host, right? We discuss about APP request. What about app reply? When this H3 sends out app request for the gateway and we have to send out app reply, right? What should be the case? It should be virtual MAC or physical MAC. App reply for IP address virtual. There is no GARP for this. Okay, so there is no GARP feature for IP address virtual, only app reply.
Should be virtual.
It should be always virtual, right? For whatever gateway, right? For gateway, it should be virtual. Otherwise, physical will again flap, correct? We know that. So
Yeah.
our gateway, whenever it requests come for the gateway, which is virtual IP, your answer should be virtual, right? So it is virtual and outer IP is also because of that virtual, right? So that's why this app reply, right? No GARP, but app reply is always virtual, right? Which is same as this guy also, right? All virtual. And this also all virtual. Only this changes. App request. And for that, we know reason, right? So yeah, let's move to. So we discuss app sync. Any question so far? So we have WARP, right? This is the physical IP and virtual IP gateway. App request will be physical so that it reaches to who has initiated the app reply, right? So that's why app request is always physical MAC, and GARP or app reply always should be virtual, because otherwise we will see flap and all that issue here, right? Because it is requesting for virtual IP gateway, and that's why this response also should be virtual. So that's why in here it's all virtual, right? And similarly here it's only for virtual IP, no physical IP. So your app request will be virtual because there is only virtual IP. So VMAC is also virtual. And because of that, your reply might consume by other VTAP. You need AppSync, and that is handled by VXLAN agent. Okay, any questions? Okay, so now let's discuss about some other rules, right? We already discussed around 1 or 2 rules. Okay, so we discussed this first rule, right? Which is if MAC is virtual, VTAP IP is virtual. If MAC is physical, this also should be VTAP IP should be physical. Okay, so that is first rule. Let's discuss the second rule. Yeah, the other one, right? Routing VTAP generates ARP reply where Ethernet source MAC of the ARP reply is virtual MAC address. This is same for GARP. All information in ARP header will be virtual, right? So basically this is again same. If we have this virtual MAC, this should be virtual, right? Everything should be virtual. So this is virtual, right? Virtual IP, virtual MAC, everything is virtual. So that is the point. And for ICMP, right, that also we discussed for ICMP traffic from H1 comes here, then we will use physical MAC, right? Physical MAC. And in that case, this also will be physical VTAP IP for ICMP. Okay. So it's all about what we already discussed, right? Now, third rule, right? This is only for IP address virtual. This is also we have discussed for ARP request and reply, right? Everything is virtual, right? So outer source IP is also virtual. So it's again same. And whenever we app reply, we send out app reply, it's virtual MAC, right? And because it's a virtual MAC, this also should be virtual VTAP IP. Okay. Okay, for ICMP packet, source MAC is physical, hence outer source IP also will be VTAP IP. Again, this rule for IP address virtual, for ICMP traffic, right? ICMP traffic, this is what we are going to do is route, right? And here where we discuss that ICMP, it will be physical, right? And when it is physical, it will be A. And this also should be physical VTAP IP. 1.1.1.1. But one challenge here is what IP? See, we already know, right? If you use physical MAC, this sender IP basically, okay. So this also will be this. Yeah, that's right. Okay. Any question on this? Sorry, I'll discuss that point in next. But yeah, this is physical. So you just remember for ICMP, it's always physical. And when source MAC is physical, VTAP IP is also physical, right? And if it is virtual, then here also it's virtual. Any question? Okay. Moving to next rule. This rule is already we have discussed. So what is that is, let's say H1 wants to communicate with, let's say H3, right? It sends out ARP request to the gateway, right? This will reply back. But as we discussed that this will replicate this ARP request because it's a flood, right? It will send this ARP request to other VTAPs as well, right? And other VTAP will reply back to this guy, right? And it will create, host flap or unnecessary ARP replies across the network, right? We discuss about this problem. How we resolve that is, we decided we have one rule, which is this one, where it will reply back only if the destination VTAP IP is 5555, right? So this VTAP receives the app request and this, but if destination VTAP IP is 555, then only it will reply back. Otherwise it will not, right? And that's what this rule to avoid unnecessary app replies into the network, okay, which we discussed before. So that's this rule that unnecessary app reply will be avoided. Any question on this rules? Okay. Now one more concept, one or two couple of more concepts Okay. So now one is, let's say, okay. Yes, request, yes. Okay. Let's say H1 wants to communicate with H3. Okay. H1 wants to communicate to H3. H3. What can happen? H1 is sending out IP address virtual. Okay. This is the configuration, not warp, IP address virtual. It resolves the gateway, right? And it sends the ICMP packet to, let's say, VTAP A. So ICMP packet has received here in VLAN 100. It checks the destination IP is SVI 200. It routes the packet from SVI 100 to 200, right? 200. Now it has to send out the R packet, right? R, resolve the R for this IP address, host 3. So it sends out the packet R request, right? So this guy will send out ARP request. Okay. What will be the sender IP? What should be the sender IP? VTAP is sending.
Should be the virtual one.
Virtual, because physical is not here, right?
Yeah.
You don't have option. So I just have to make this here, right?
200.
200, 200, right?
Mm-hmm.
Both SVIs are configured at both the devices. Okay, so this guy has to send out, basically it has to use the virtual IP, right? App request.
Mm-hmm.
And target is what? 200.112.
200.112.
Right?
Yeah.
What is the source MAC? Which source MAC it has to use?
VMAC.
VMAC, right? Because this is virtual, correct?
Mm-hmm.
Destination MAC, it don't know, right?
Yeah.
0000. It has to get it. So sender, Ethernet sender MAC, source MAC, VMAC, right?
Mm-hmm.
And this is FFFF, right?
Mm-hmm.
And it has to flood this traffic because it doesn't know, right? Based on flood HER, hidden replication, that what is the, so, okay. Basically it has to flood this traffic to all the VTAPs because it does not know behind which VTAP this H3 is, right?
Mm-hmm.
What should be the sender IP, outer sender IP, source IP?
555.
Why? Because it's VM,
it's virtual.
virtual, right? So 555. Now what will happen? This will receive, this one packet will go here, right? One will go here, this VTAP, another will go this VTAP. What will happen? They will decapsulate the packet, remove this, right? And it will flood the traffic. So it will flood here. This guy also will flood here on all the ports. Who will reply back at 3 because it's its own IP address. It responds back with reply packet, right?
Mm-hmm.
Now it will encapsulate what should be the, what will be the app reply packet from exiting from here. Let's take this here, right? What should be the app reply? This is what destination outer IP should be.
555.
555, right? Source IP should be
333.
3333. Destination MAC is what? Which MAC? From where it came? VMAC, right? VMAC. Source MAC? H3. H3 is replying, right?
Yeah.
And here also destination is VMAC. H3. Source IP is 2, right? 2. Reverse. And this is 10. Okay.
Yeah.
So it has replied back. It came here to spine. What spine will check? What is the destination IP?
5.
555 is here also. It's here,
Yeah.
right? So this packet might go send here, here, or here, anywhere, right? Who initiated app request for H3? This guy.
Yeah.
Let's say spine sends this packet to VTAP2, right? Possible because destination is 555. What will happen? It will check the destination MAC VM. It has its own VM virtual MAC, right? And this everything matches. It will consume the packet. ARP will be updated. Make sense, right? Clear? Is it right? Yes or no?
Vishal,
This can
you're
happen or not? Oh,
You're breaking out.
oh, sorry. Is it clear now? Are you able to hear me?
Yeah. Now it is okay.
Okay. So basically my point is that this can happen, right?
So it receives the ARP reply.
It receives
VTAP2.
VTAP2 might receive app reply and it updates its own app table, right? But our problem is who has sent app request might not receive app reply, right? In this situation, is it possible?
Yeah.
Right? So what should be the means how we should solve this? How can we solve this? See, same problem you have seen here within this part, right? What happened? Yeah, this guy sent app request, reply received here. It is virtual MAC, it consumed. So what you did? ARP sync, right? Similarly, for IP address virtual, we also have another command or another feature which is called ARP reply sync, relay reply sync. Reply sync, okay, reply sync. That is for this type of scenario what we discussed. So it is possible that ARP VTAP1 has sent out ARP request. It might land here and this will update its ARP, but it will not reach to the original VTAP who has started, initiated. So in ARP reply sync, what we do is whoever receives routing VTAP receives the ARP reply, right? It generates or creates an ARP reply, copy of ARP reply and send it to all the VTAPs based on flood list. So this ARP reply, it has received, it will update its own, but it will send that ARP reply copy to other VTAPs as well, so that eventually this VTAP or this VTAP will also get that ARP reply and it will update their ARP packet. So that is the feature of ARP reply sync. Is it clear? So we have two ARP feature. One is ARP sync, which is within MLAC pair, and another is across VTAP pairs where you need ARP reply sync with IP address virtual. This is only for IP address virtual. Because for VARP, you send with physical. Okay, for VARP also it's a virtual, right? So yeah, for that also I think yeah we need this. Yes, not this one. Oh, this is only for this IP address. Yes. For VARP, I think we don't need this. Maybe yes. So is it clear?
Yeah. For VARP again, it will use the physical one, right? So it should.
Oh, 1 minute. Yeah, VARP is physical, right? ARP request is physical. See, that's the point. See, even I forget, right? It's not easy. I also need to again, think, hey, what was that, right? So don't means you might not remember everything. I also have to think, hey, what should be the case, right? But yeah, if your concepts are clear, I think you should be able to get it right after thinking. So this feature is only needed for IP address virtual, because for VARP you are sending ARP request or GAR with physical MAC, and that's why it will land on this VTAP only who has originated. Okay. Okay, any question? Okay, so now this is the last topic, which is what, so many times, right, when we do troubleshooting, what we do, let's say this H3 is not able to ping to H1, right? What most of the time we do or try to do is we ping from this switch, right, or gateway to this H3, right? And then we get reply, then basically we narrow down that, hey, this path is clear, this path, we try to ping here to here and here to here to see which path has a problem, right? Many times we do this, but this might not be helpful when we try to ping from VTAP to the host, right? This way might not be helpful in VXLAN case. Reason for it is, let's say you are sending out ICMP packet, right? You are sending out ICMP packet, ICMP request. Target IP is what? 200.112, right? What is the sender IP? Oh, sorry, this is ICMP. So we should remove this, right? So source IP and destination IP, destination IP, right? DIV. Destination IP is 200.112, this guy. What should be the source IP? 1110, right? This. We don't have physical IP, right? If this is virtual, then this also should be virtual VM, right? And then everything is again, so outer sources, this is virtual, and then we know that H3 is behind, say 333, so we send it to 333. What will happen? This might land up anywhere because this is virtual MAC, right? So that is one problem. So basically what we do is, and as we discussed, right, for data traffic, this is ICMP, we use physical MAC. So basically we are going to use physical MAC, right, for data traffic. If we use your physical MAC, one rule which we have decided that this also should be physical, right? Source IP, right? We are initiated ping from here, right? So this also should be physical because we want to use physical IMAC, right? But there is no physical IP configured here, right? It's all virtual. So what we do is, to fulfill this requirement, we need to use physical IP. So what we use loopback IP address, highest loopback IP address on the switch as a source IP address. When we initiate ping from VTAP itself, switch itself. So this is the condition when you initiate a ping from VTAP, instead of taking virtual IP address, because we can't, because this is physical, right? It will mismatch. We need to take physical IP address. And because on SVI, there is no physical IP address, we take any physical IP address, which is highest as per router ID and that rule, right? So any loopback highest IP address. That is called natting. So basically we do natting of this IP 100 instead of 200, 1110 virtual, we nat it with physical IP address and send out this request. Okay. And obviously, if this is physical, here also it will be physical VTAP IP. Okay. Now, what can happen? See, host might, or this VTAP might don't know how to read this physical IP address, because it can be any interface IP address, highest IP address, or loopback highest IP address, which is not advertised underlay, right? So H3 or VTAP might not be able to reply back because this route for the source IP is not available. So that's why, that's the reason, because we do natting when we initiate packet from the switch or VTAP, right? And in that natting IP can be anything, right? That's the reason that it's not good idea for validation in VXLAN to ping from the VTAP, because it might not work, because the route at other end for this source IP is not there, which will be destination IP. Is it clear?
Yep.
Okay, so you can just remember that don't use, ping from VTAP, or even though customer is using it, ask him to not to use and just try to ping from host to host. When you where your VTAP is transit data traffic. Okay. Because we do netting if we ping from here. Okay. Yeah, so I think that's it from VXLAN perspective. Any questions?
No, I'm good.
Okay.